Good morning. I am Dr. P. Ilamurkan, Professor Biomedical Engineering, and I am handling the subject Consumer Electronics and Smart Systems for third year students. And on the consumer electronics, so in our day-to-day life, we are everyone having the smartphones. The smartphones are belongs to the consumer electronics, even the laptop. So what is the power required to the laptop? The power required to laptop is 12 volt, and for mobile is 6 volt. So both are in DC quantity, whereas from the power supply we are using the AC quantities, 2 volt, 230 volt AC we are using in the main supply. Okay, so consumer electronics require the low voltages. Mostly they are preferred to the electronic devices. So our unit number 1 is electronic fundamentals. We will be in the unit 1. The cover topics are semiconductor devices, diodes, transistors, logic gates, integrated circuits, Moore's law, and analog to digital converter and digital to analog converter, introduction about microcontroller and microcontroller in consumer electronics. So these are the topics covered in the unit number 1, and first we are going to see about the semiconductor devices, and in particular we are going to see about the diode. Okay, so the diode is normally a PN junction diode. So what is semiconductor? So what are the terms related to semiconductor? Means the term related to semiconductor is conductor and insulator. So conductor is the conductor of electricity, whereas insulator is a not conducting or the poor conductor of electricity. Whereas semiconductor, it conductor electricity at times and it will not be conductor electricity at times. Okay, so semiconductor lies between the conductor and insulator. So semiconductor is a material which conducts electricity at particular conditions. Okay, so there are two types of semiconductors. One is intrinsic and extrinsic. So we are mostly prefer the extrinsic semiconductors. So extrinsic semiconductor means, so by adding the impurities, it will be in the element, maybe the material may be conducting the electricity. Okay, for example germanium and silica. Okay, and in particular there are two types of extrinsic semiconductors. One is N type and another one is P type. In N type, electrons are the majority charge carriers, while the holes are the minority charge carriers. So electrons are negatively charged particles, where the holes are the positively charged particles. In P type, holes are the majority charge carriers, and while the electrons are the minority charge carriers. So in N type, electrons which are negatively charged particles are the majority charge carriers. In P type, holes which are positively charged are the majority charge carriers. These P and N, so these electrons and holes are combined together to form a electron hole pair. So that the pairing, where the region where the electron and hole are pairing is known as the PN junction. Let us see detailedly in the next slide. So here is the PN junction diode. So the PN junction diode is a two-terminal device. So this two-terminal device, which is used to conduct is a semiconductor. It's a two-terminal semiconductor device. The two terminals are anode and the cathode. Okay. So here we can able to see that in the P type, the holes are the majority charge carriers, which are positively charged particles, and they are ready to accept the negative ions. In N type, electrons which are negatively charged particles are the free electrons. They are the majority charge carriers, and they are ready to accept the positive donors. Okay, here is the construction of this PN junction. Okay, so we are taking in a P the two layer. There is a P and N are the two layers, and the P contains the holes, the majority charge carriers, and N contains the electrons are the majority charge carriers, and the holes are ready to accept the negatively charged ions, and N ready to accept the positive ions. Okay, so when based on the concentration of the ions, they combine to form a electron hole pair. The electron hole pair, the electron hole pair, this region is known as the depletion region, where the electron and the holes recombine to form a layer. That layer is known as the depletion layer. Okay, and we see the forward bias when this P and N are forward bias when the battery is connected to the in a forward condition. Suppose positive to positive and negative to negative, that is positive to P side and negative to the N side. Okay, so in the P side, where the holes are the positively charged particles, so when the positive supply is given to this P region, so positive will be repelling together, so this positive ions will be moving towards these electrons, and the and this negative, this voltage, this negative voltage is given to this N side, where it contains already contain the negative electrons here, and this electrons will be repelling together, and based this repelling will be moved towards, attracted towards the positive holes. Okay, so and this will be forced to form a electron hole pair. So in this forward bias condition, the width of the depletion layer will be very small, and due to when the current increases, when the potential voltages increases, the current will be increasing. When the current increases, the width of the depletion layer also will be increasing, that is the whole electron pair will be increasing. Okay, so this is so when the potential voltage in the power supply, when the potential voltages increases, the current is increasing, is shown in this graph. Okay. The response for this germanium is 0.3 volt, and for silicon is 0.7 volt.